So let us consider this question. Solve the following differential equation. Y point point plus 9y is equal to 0. And the second question, y point point minus 6y point plus 25y is equal to 0. And the last question, y point point minus 5y point plus 6y is equal to 0. If you have this, how can you solve the following differential equation? This is a what? This is a what? Homogeneous differential equation. It's a second homogeneous. This is a second order. So we have order 2. The second order homogeneous. This is also their second order homogeneous differential equation. So how can we solve it? And when we talk about a second order homogeneous, it's in form of a y point point plus b y point plus c y is equal to 0. If we have a general form of this, we call it a what? A second order homogeneous. That is, our g of x is equal to 0. And if our g of x is not equal to 0, we call it a what? Non-homogeneous. So you can see that what? This question is an homogeneous. That is a second order homogeneous. That is, here is equal to what? 0. So how can we now solve this? You can see that the coefficient of y prime and the coefficient of y prime is b, and the coefficient of what? Y is c, which is what? Everything is equal to what? Equivalently to 0. So it means our a here, the coefficient of a here is what? 1 plus the coefficient of y prime here we don't have. Since we don't have is 0, and the coefficient of what? Y here is what? C. That is, our a is 1, our c is what? 9. You can see that it's forming what? Second order. You can see this also. This is y prime prime. That is a. Then the coefficient of a. This is coefficient. This is a. That's ay prime minus this b. Here is minus 6 plus c. Since it's a constant term, it can represent any value, which our c is what? 25. So how can we now solve question 1, question 2, and question 3? Since it's an homogeneous question, how can we now solve it? In solving a homogeneous, we assume that y is equal to what? Summation ms. So let us consider it now. So question 1, y prime prime plus 9y is equal to 0. Remember that if I have y, this is y. So if I differentiate y, what am I going to have? I'm going to have dy over dx. If I differentiate dy over dx, what am I going to have? D square y all over dx square. If I differentiate again, I'm going to have what? The 3y dx cube. So it means this is our y here. You can call it as y prime. This is y prime. This prime means this y prime. This is y prime. That is first order. That is first derivative. So this is what? Second derivative or second order. Y prime prime. Because I differentiate it twice. And this is what? Y prime prime prime. So this is what it means here. So if I have y prime prime, it means what? I differentiate it what? Twice. So let us now consider that. So let's assume y is equal to summation ms. We assume y as a what? Summation ms. If I now differentiate, if I find y prime, what am I going to have? I'm going to have what? I'm going to have, if I differentiate this, what am I going to have? I'm going to have m summation ms. If I differentiate again y prime prime, I'm going to have m squared summation ms. It means when I'm dealing with my differential, when I'm dealing with exponential, if I'm dealing with the exponential, if I'm differentiating exponential, I'm going to differentiate the power of that exponential is raised. So the exponential is raised to the power of what? Mx. I will differentiate with respect to x. If I differentiate x here, I'm going to have 1. 1 times m. The value will come down, will multiply everything. So that's why I have m exponential ms. If I differentiate again, it means this is a product. I can apply product or take differentiate only m here, x here. If I differentiate x here, I'm going to have 1. So I'm going to have 1 times m times m squared summation ms plus, if I take this again, differentiate with respect to what? X. Since if I take this one, differentiate this one with respect to x, since it's not x, it will give me 0. Everything will be 0. So that's why I have m squared exponential ms. So I will now substitute all these things in giving the equation. Whenever I see y prime, I put this. Whenever I see y prime prime, that's the second order, I put this. Whenever I see y, I put summation ms. So this is how we are going to what? Solve this. So what is our y prime prime? It means put y prime prime in this. I'm going to have m square summation ms is equal to, what is my plus 9? What is my y? My y is what? Summation ms is equal to 0. We assume that this is the what? How can we solve it? So I just assume that it is. So this is how what? This is how to solve the question. We have to assume. So when you assume it, you differentiate it, you now to substitute it into it. So what are you going to do next? I can factor this out. What is the common factors of this summation ms? Or I divide both sides by what? I divide through by summation ms, so that summation ms will be able to cancel, since it's the common term between them. So I'm going to have m square summation ms plus 9 summation ms is equal to 0 all over what? Summation ms all over what? Summation ms all over what? Summation ms. This will cancel, this will cancel. So what am I going to have here? I'm going to have m square. So I'm going to have m square plus 9 is equal to 0. So m square plus 9 is equal to 0. So I can take, this is a constant, I can take 9 to the right hand side. I'm going to have m square is equal to 0 minus 9. I'm going to have m square is equal to minus 9. So what am I going to do here? I want to solve for m. What? I want to get value for m. What am I going to do is what? I'm going to what? I'm going to what? Take the square root of both sides. I'm going to have m square root is equal to what? Minus 9 square root. M will cancel, square will cancel square root. I'm going to have m is equal to. Remember that whenever we have a square root of negative of any square root of negative, remember that our I is what? Minus 1. That is, I give us what? Minus 1. That is minus 1 times what? Root 9. I can write this as this. Minus 1 times root 9, I'm going to have minus m is equal to, what is my minus 1? Minus 1 is I. In complex analysis, minus 1 is what? I times, so square root of 9 is 3. So I'm going to have m is equal to what? 3i. So for me, I will now get m is equal to 0 plus or minus 3i. Remember that when I'm taking a square root, I'm going to have negative, positive, and negative. So since we don't have anything here, is what? Is negative, is 0. So plus or minus 3 here. So my m will now be 0 plus 3i, or m is equal to what? 0 minus 3i. So this is what? Is an auxiliary equation. Since because I want to solve for y, I got it. We call this as auxiliary equation. When you have this to do, is what we want to get y of s having an imaginary part. I'm going to have alpha and beta. So for me to have my y of x, my alpha will not be my 0. I will have exponential alpha s into c cos beta s plus d sine beta s. So this is what I'm going to have. That is where my alpha is my real part, where my beta is my imaginary part. So real part is what? Is the part that does not have what? Imaginary unit or iota, which is what? 0. While my beta is what? Is my imaginary part, which is what? Having what? Iota, which is what? 3. So I will now substitute this inside this. So now I'm going to get my what? I'm going to get my y of x. So my y of x will now be exponential. What is my alpha? Alpha is 0. X is equal to c cos. What is my beta? My beta is what? 3. Multiplied by s, 3s plus d sine 3x. So anything exponential to the power of 0. 0 times s, I'm going to have 0. So y of s is what? Exponential 0 is what? 1. So I'm going to have 1. So I'm going to have c cos 3s plus d sine 3s. So this is the solution for this. So it means we have solved this. In some places you might find that they will not use c, they can use a, they can use b. Since it's a constant term, it can be a cos 3x plus b sine 3x. It can be c1, it can be c2. Since it's a constant term, it can take constant term, take any value, any letter. So let us now consider the second example. Y prime prime minus 6y prime plus 25y is equal to 0. So I'm going to assume that y is what? I will assume that, let's assume y is what? Summation ms. Then y prime is what? M summation ms. Then y prime is what? M square summation ms. I will now put this, that is, put y prime and what? Y prime is equal to this and y into this equation. So I'm going to, so y prime is what? M square summation ms minus 6. What is my y? My y is what? Summation ms. My y prime is m summation ms, then plus 25. What is my y? My y is what? S summation ms is equal to 0. So what am I going to do here? I can factors the common terms or divide through by what? Exponential ms. Since exponential ms is common, so if I divide both sides, this will cancel this, summation ms will cancel summation ms. 0 divided by any value will give us 0. So I'm going to have m squared minus 6m plus 25 is equal to 0. You can see that this is an auxiliary equation. And the auxiliary equation is form an auxiliary equation. When we talk about an auxiliary equation, that is form an equation that we can apply a formula to it to solve, so we can get the value for m. You can see that this is a quadratic. It's a quadratic equation, that is, the power is what? 2. It's a quadratic equation. So we will now find a formula. To use. We cannot apply factorization method here. Why? Because we cannot find a 2 number that we are going to add that's going to give us minus 6, and that we are going to multiply the product of it to give us 25. We can easily use general equation. So if you easily use the general equation, what are you going to have? I'm going to have general equation, general formula rather. I'm going to have by quadratic formula. So by quadratic formula, so it will be m is equal to minus b plus minus b square minus 4ac all over 2a. So what is my a here? The coefficient of m square is 1. It will be my a. The coefficient of m is my b, which is what? Minus 6. And the coefficient of c is my 25. And c is what? 25. I will now plug this into this. So I'm going to have m. Since I'm finding value, I want to get m. That's why I'm using m. So I'm going to have m is equal to minus b. Minus 6 plus or minus b square. B square is minus 6 to the power of 2 minus 4 times 1 times 25 all over 100 all over 2 times a, which is 1. So I'm going to have m is equal to 6 plus or minus 36 minus 4 times 25. I'm going to have 100 all over what? 2. So m is equal to 6 plus or minus 36 minus 100. I'm going to have what? 64. I'm going to have minus 64 all over 2. 36 minus 100. I'm going to have negative 64. So remember, m is equal to 6 plus or minus. So what is my minus 64? Remember that square root of 64 is what? 8. And negative 1 will give us I. So I'm going to have 8i all over what? 2. So I will now solve this. M is equal to what? 6 plus 8i all over 2, or m is equal to what? 6 minus 8i all over 2. That is, I first take the positive 6 plus 8i all over 2, then I'll now take the negative 6 minus 8i over 2. So my m here will now be, how many 2 will you see in 6? 3 plus 4i, or m is equal to, how many 2 will you see in 6? 3 minus what? 4i. So this is the equation. And remember that whenever we have an imaginary part, we are going to use what? We are going to use this. It means if our solution is imaginary part, we are going to consider this general solution. So it means my y, that is my alpha, is the gray part, which is 3, my beta is my imaginary part, which is 4. So I'm going to have y is equal to what? Exponential alpha s. I'm going to have exponential. What is my alpha? 3x. Then what is my c cos b beta s? So what is my beta here? 4 multiplied by s plus what? D sine 4s. So this is the general solution to the answer. And if our answer is not in imaginary part or real part, there's another way to do it. If our answer is not in real part, there's a general solution that we are going to get will be different from this. But if our answer is in form of, if our auxiliary equation is in form of real part and imaginary part, anything this with imaginary part, our general solution will be in this. That is, our particular solution will be in this. So let us now consider the last example. Y prime prime minus 5y plus 6y is equal to 0. So let us consider the last question. So we assume that, let's assume y is equal to summation mx. If we differentiate this, that's y prime. I'm going to have m exponential ms. If I differentiate again, y prime prime, I'm going to have what? M squared exponential ms. So I will now plug in or put in this into this equation. So this y prime prime is what? M squared exponential mx minus 5. What's my y prime? I will 6. What's my y? Exponential ms is equal to 0. So what am I going to do next? I can divide 2 by what? Exponential ms, or I can factor this out. So let's divide. I'm going to have exponential ms all over exponential mx all over what? Exponential mx, then exponential mx. This will cancel. I'm going to have m squared minus 5. This will also cancel. 5m plus 6 is equal to 0. So if we check this is an auxiliary equation. And for us to get our auxiliary, we have gotten our auxiliary equation. So that equation we have an equation which is a quadratic equation. And so how can we now solve this auxiliary equation? We can apply our general formula, that is general quadratic formula, or we factorize. So let us factorize. It means I'm going to look for a 2 number. If I sum it, I'm going to have -5. Then if I find the product, I'm going to have 6. So the 2 numbers are what? 2 and 3. It means if I have minus, if I have -2 and -3, the sum of -2 minus 3 will give me -5. And the product of -2 and -3 will give me what? 6. So I will now have m squared minus 2m minus 3m plus 6 is equal to 0. So I can group it by grouping m squared minus 2m minus 3m plus 6 is equal to 0. So if I group, so what is common? The common term here is m minus 2. Then what is here? Minus 3. M minus 2 is equal to 0. If I use m to multiply this, I'm going to have this m times m squared minus 2m. If I use minus 3m to minus 3 times m minus 3m, minus times minus, bracket is times, minus times minus is what? Plus. Minus times minus is plus 6 is equal to 0. So I'm going to have this. Since this one is the same, I'm going to take it as ones. You know the laws in factorization. I'm going to have it the same, and if it is the same, I'm going to take it as ones and take the second one. So I'm going to have m minus 2, and m minus 3 is equal to 0. So m minus 2 is equal to 0, or m minus 3 is equal to 0. So I'm going to have m is equal to 2, or m is equal to 3. You can see that I've solved that auxiliary equation. So what will now be the general solution to this? Whenever I have, you can see that our first and second one is different from the answer we got. When we did the first time, we have an imaginary number. That is, we have real part and imaginary number. But here we're not having a what? Imaginary number. So it means whenever you have something like this in form of 2 positive number or even negative number, which are not the same, my general solution will be a exponential ms plus b exponential ms. Since our m is equal to 2, I'll now say y of x is equal to a exponential. What is my m? 2x. M is what? M is 2. 2x plus what? B exponential what? 3x. It means whenever I see m, I put 2. Then whenever I see m here, I put 3. This one will take 2. This one will take 3. Or this one can be 3. Or y of x can be a exponential 3x plus what? B exponential 2x. It's still the same thing. If you don't want to use a and b, you can use c1 exponential 2x plus c2 exponential 3x. Either way, it's also the same since c1 and c2 are constants. So that is the general solution for this. So what if suppose my answer is m is equal to 2 or m is equal to 2. That is, I have 2 and 2. Whenever I have a word same root as my answer, my general solution will be y of s is equal to a exponential ms plus b s exponential ms. Because my real root is what? Is the same. When I have the same answer, that is my real root is the same. My general solution will be this. So my y of s will now be a exponential 2x plus bs exponential 2x. So this, it means if my real root is the same, that is having the same root, I'm going to have what? My general solution will be in form of this. But if it's not the same, maybe it's 2 or 5 or something, my general solution will be in this. And if it is what? If it is in real, and if my solution is also maybe in real number, imaginary and real number. So I'm going to have what? Y of x. I've explained that exponential alpha s c cos beta s plus what? D sine beta s. So these are the general solution in homogeneous. I hope you find it interesting. Subscribe to my channel.